This lesson is on scalar multiplication. I want to start out by talking about multiplication with matrices, because when you see multiplication here, you might think that we're going to be taking two matrices and multiplying them together. And then you might think, if it's similar to adding and subtracting, that you would take the numbers and the corresponding elements, like 20 and 11, and multiply them together and get 220, and so on. This is not how multiplying matrices works, and we are not even going to be multiplying matrices in this lesson. Scalar multiplication is different. Scalar multiplication, the scalar just basically means that you're taking a number and then multiplying just that one number by an entire matrix. So couple things, that's what scalar multiplication is. And then once again, multiplying matrices is not the same as adding and subtracting. It's more complex. So that is something we can discuss later. So this mall problem is continued with November and December shipments at malls 1 and 2 of t-shirts, so we can see how many small, medium, and large each mall had in each month. And example 1 says, because inventory was low, the local malls received twice the amount of shirts in January as they did in December. Write a matrix to represent the shipment of each size to each mall for the month of January. So we have information November and December, but now the problem is, all right, let's add in a third month of January. And if the malls received twice the amount in January as they did in December, really all we need to use here is this December information. So what I'm going to do is I'm going to take the matrix for December, which row 1 is 11, row 2 is 28, row 3 is 14. I'm sorry, I keep saying row. They're all row 1. That was column 1, 2, and 3. Now in row 2, the numbers are 17, 27, and 12. And our labels here, we have mall 1, mall 2, small, medium, large. Actually, to show the work here, I might leave off the labels and then just put them with my final answer at the end. So if I want to know what the numbers are for January, and January is twice December, I'm going to put a 2 in front. That's what we call the scalar. And now we're multiplying that 2 by this matrix. It's a 2 by 3. So the 2 is going to multiply by all 6 of the numbers in that matrix. That's how scalar multiplication works. So when I take 2 times 11, I get 22. 2 times 28 is 56. 2 times 14 is 28. 2 times 17 is 34. 2 times 27 is 54. And 2 times 12 is 24. And if I just include the labels now with my answer, I've got small, medium, and large for those columns. This is mall 1 and mall 2, and there is my answer. So with scalar multiplication, once again, it just means that each element in the matrix is multiplied by the scalar, that number out in front. So we're going to try 2 examples down below to practice this, starting with example 2. Here the scalar is a 3, so it's kind of like, if you think of distributive property, the 3 is sort of distributing to all those elements, and each of those 6 numbers is getting multiplied by a 3. So you don't have to show work here. If you want, you can show like 3 times negative 1, 3 times 3, 3 times 2. I'm just going to go ahead and put those answers right away. So when I do 3 times negative 1, I get negative 3. 3 times 3, I get 9. 3 times 2 is a 6. And in row 2, 3 times 5 is 15. 3 times negative 4 is negative 12. And 3 times negative 3 is negative 9. And there's my answer for part A. All right, part B. We are going to be doing scalar multiplication here, and then we're also going to be subtracting. So I'm going to kind of think of this as, first, I want to multiply everything in this matrix by the number 4. And I want to multiply everything in this second matrix here by the number 3. And I'm going to leave that minus sign and then take care of the subtraction step after I do the scalar multiplication for each part. So on the left side of the minus sign, When we multiply 4 by that matrix, 4 times negative 1 is negative 4. 4 times 5 is 20. 4 times negative 2 is negative 8. 4 times 0 is 0. Now on the right side, remember I'm leaving the negative and I'm just multiplying 3 times 3, so positive 9. 3 times negative 2 is negative 6. 3 times 1 is 3. 3 times negative 4 is negative 12. Okay, now I have a subtraction sign in between, so I'm going to be subtracting. So when I take negative 4 minus 9, that's negative 13. A 20 minus negative 6 becomes 20 plus 6, which is 26. In the second row now, column 1, I have negative 8 minus 3, which is negative 11. And then to the right of that, I have a 0 minus negative 12, which is the same as 0 plus 12, which is 12. I'm going to switch colors up here and show you one more option. Instead of just using 3 to multiply by everything, you could have used the negative 3, which would have given you a negative 9, positive 6, negative 3, positive 12. And if you did that, then this would have been a plus. And notice you get all the same answers. A negative 4 plus a negative 9 is a negative 13, and so on. So it, you could think of it either way, as you're kind of distributing that negative 3 and then adding, or keep the minus, just distribute the 3, then subtract. Either way, you should get the same answer. So this concludes our lesson on scalar multiplication.